Hello student, I welcome you all in online lecture series. Today we are going to discuss numerical method, that is trapezoidal rule and Simpson one-third rule to find the integration of given equation from computational physics. Welcome dear learner. We are discussing about the numerical method in computational physics. Friends, in previous lecture we discussed about the Newton-Raphson method. The numerical of a Newton-Raphson method, then algorithm, flowcharts and programs of a Newton-Raphson method. We know that the Newton-Raphson method is used to determine a root of a given equation, and the root of a given equation up to particular iteration can be found by using formula x1 is equal to x0 minus f of x0 divided by f dash of x0, and this process is carried out up to which we get the appropriate root of the given function. In this lecture we have to see trapezoidal rule and Simpson one-third rule, algorithm, flowchart and program to find the integration of a given function by using trapezoidal rule and Simpson one-third rule. We know that the trapezoidal rule is used to find the integration of a given function, and the formula is the integration of x0 to xn y dx is equal to h by 2 in bracket y0 plus yn plus 2 in bracket y1 plus y2 plus y3 up to so on yn minus 1. And the Simpson one-third rule is the integration of from x0 to xn y of dx, it is equal to h by 3 in bracket y0 plus yn plus 4 in bracket the odd term, that is y1 plus y3 plus y5 up to so on yn minus 1 plus 2 in bracket even term, that is y2 plus y4 plus y6 up to so on plus yn minus 1. So in this h is a step size, that is h is equal to xn minus x0 divided by n, where xn is a last limit, then x0 is initial limit, then n is a step size. We can find y0 by using formula, that is y0 is equal to f of x0, y1 is f of x1, yn is f of xn. So by using this formula we can determine the integration of a given function. So in this lecture we have to see algorithm, flowchart and program to find the integration of a given function. So after attending this lecture, student will be understand about how to find the integration by using trapezoidal rule and Simpson one-third rule. Algorithm is our first step is read x0 and xn, where x0 is a lower limit and xn is a upper limit. Then read y is equal to fx, that is given function. Then we have to calculate f of x0, then f of xn. This is our second step. Third step, we have to read the number of strips of integration, so that read n. N represent number of strips. Then calculate step size. Step size can be found by using formula h is equal to xn minus x0 divided by n, where xn is a upper limit, x0 is lower limit, n is the number of strips. Then step 5, consider sum is equal to 0. Then step 6, I is equal to 1. Now we have to initialize I is equal to 1, where I is loop index. Step 7 is x is equal to x0 I into h, where x0 is a lower limit, I is 1, value of I is 1, and h is a step size, so that we get second step. Okay, that is x is equal to x0 plus I means 1, h is a xn minus x0 divided by n, so that we get second step. Then sum is equal to sum plus f of x0. Here we initialize sum is equal to 0, and therefore sum is equal to 0 plus fx. Then I is incremented by 1, so that we use I is equal to I plus 1. Now we have to check the condition. I is incremented by 1 up to I is less than n. When I is less than n, this condition is satisfied, then go to step number 7. That is, again repeat the step. That is, x is equal to x0 plus I into h. In this case, I is incremented by 1. I is initialized as 1 and incremented by 1, so it became 2. Again, find sum is equal to sum plus f of x0. That is, function f of x. Okay, again I is incremented by 1. This step is carried out up to which I is less than n. When this step is true, that is I is less than n, go to step number 7. But if this step is false, that is I became greater than n, then step 11 is sum is equal to 2 into sum. 2 into sum. Then step 12, it is equal to, that is integration I is equal to f of x0 plus f of xn. F of x0 means y0. F of xn means yn. Okay, f of x0 plus f of xn means y0 plus yn plus a sum. Now sum we calculated in the above step, that is 2 in bracket y1 plus y2 plus y3 up to so on yn minus 1. This is the sum, and y1 is f of x1, y2 is f of x2, y3 is f of x3, and yn minus 1 means f of x minus n. And the value of x is found by using formula x is equal to x0 plus I into h. Okay, and the bracket is a multiply by h by 2, because our formula of a trapezoidal rule is h by 2 in bracket y0 plus yn plus 2 in bracket y1 plus y2 plus y3 up to so on yn minus 1. Then we have to print the integration, then end or the stop the program. Now we have to see what is the flowchart for this trapezoidal rule. Flowchart is a pictorial representation of an instruction. Okay, and therefore first step is a start, then read a lower limit and upper limit. Lower limit is x0, upper limit is a xn. Now read the number of iteration or number of strips, that is n. Then we have to calculate the step size by using formula h is equal to xn minus x0 divided by n. Then consider sum is equal to 0, okay, and I is equal to 1. Next step is x. Find x is equal to x0 plus ih. Here we get value of x is, that is x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, x3 is equal to x0 plus 3h, so on. Okay, first I is equal to 1, sum is equal to 0, then find x is equal to x0 plus I into h. Now sum is equal to sum plus fx. Sum is equal to 0, 0 plus fx. Okay, when x is equal to 0, then it is f of x0. Okay, for first value. For nth value, it is yn is equal to f of xn. Okay, then I is incremented by 1. Now we have to check the condition. If I is less than n, if this condition is satisfied, then find value of x. Again, x is equal to x0 plus ih. I is 1, so it is become x0 plus h. When I is incremented by 1, then it became x is equal to x0 plus 2h. Again I is incremented by 1, then it became x0 plus 3h. Then again I is incremented by 1, then it became x is equal to x0 plus 4h. This process is carried out up to which I is less than n. But when this condition is not satisfied, then goes down. Sum is equal to 2 into sum, that is 2 in bracket f of x1 plus f of x2 plus f of x3 up to so on f of x minus n. Then the integration, we can find the integration by using formula I is equal to h by 2 into f of x0 plus f of xn plus sum. Then stop, print I and stop. This is a flowchart. Now we have to see the program to find the value of integration by using trapezoidal rule. First is a hash include stdio.h. Hash include is a preprocessor directive. stdio.h means standard input output function. .h means header file. Here we use a printf and scanf function, which are the standard input and output function, and therefore we use stdio.h. Hash include conio.h. Conio.h is a use because in this program we use clear screen and get ch. Then we have to perform the mathematical operation, and therefore we use hash include maths.h. Then define the function, that is define hash define fx, that is a function. The function is 1 minus x square, so that it can be written as 1 minus x into x. Then void main, we use some codes, and these codes are executed only when we use this function, void main function. The body of a program is enclosed in a pair of curly bracket, and there this is the opening curly bracket, and the program is end with the closing curly bracket. Then floats x0. X0 is a floating point variable because it consists of a decimal point. That is, the initial limit may be consist of a decimal point. Xn is upper limit, which also consists of a decimal point, and therefore x0, xn, h. When we calculate the step size, that is h is equal to xn minus x0 divided by n, it may be consist of a decimal point, and therefore we consider it as a float. Then initialize s1 is equal to 0, s2 is equal to 0, and x, which is also floating point. Then n and I, these are the two are integer. So this is the initialization of a variable. First is a floating point variable, and second is a integer. Then clear screen. Clear screen is used to clear the previous output. Then printf function, we use a printf function here. Enter the value of x0. Now this message is a display on a screen. Enter the value of a x0. This message display on a screen. Printf is a output function which is used to display particular message on a screen. That message is enclosed in a double inverted comma and terminated with the semicolon. Then when we see the message, that is enter the value of x0, now we have to enter the value of x0. For that we use the input function, that is a scanf function. Scanf %f, why %f? Because x0 is a floating point variable. Then x0 is enter or given to the computer by using this input function. Then now we have to enter the upper limit. For that the message is a display on a screen, that is enter the value of xn by using output function, that is a printf function. Now we have to enter the value of xn, and for that we use the input function, that is scanf %f. Again xn is consists of a decimal point or a floating point variable, and therefore we use the scanf, which is the input function, and xn. Now we have to enter the number of strips. Okay, so enter the number of value of n. Again this message is a display on a screen by using the output function printf. Okay, now we have to enter the value of n. N is an integer, and therefore we use here %d, and the input function is %d and n. By using this input function we enter the value of n, or we give value of n to the computer. Now we have to find the step size by using formula xn minus x0 divided by n. Now s1 is equal to s1. Here s1 is equal to 0, which we initialize in a floating point variable. F of x0 means y0 is equal to f of x0, okay, plus f of xn means yn. So s1 is y0 plus yn. Simply s1 is y0 plus yn. Now we use a for loop, and in a for loop first is the initialization. We initialize I is equal to 1. I is equal to 1. Then I is incremented up to I n minus 1, because now we have to find the term 2 in bracket y1 plus y2 plus y3 up to so on yn minus 1, that is f of x1 plus 2 in bracket f of x1 plus f of x2 plus f of x3 up to so on f of x minus n. Okay, so for that we initialize I is equal to 1. I is incremented up to I is less than or equal to n. This loop is executed up to the condition is satisfied, that is I is less than or equal to n minus 1. Okay, now calculate x is equal to x0 plus I into h. First I is equal to 1 and therefore x is equal to x0 plus h. When I is equal to 2, it is x is equal to x0 plus 2h. I is 3, it became x0 plus 3h. Then calculate x2, s2. s2 is equal to s2. s2 is a 0, which is initialized when we initialize the floating point variable, plus f of x0. Okay, f of x0. Then I is equal to h by 2 into s1, means f of x0 plus f of xn plus 2 into s2, means f of 2 into s2 means f of x1 plus f of x2 plus f of x3 up to so on f of x minus n. Okay, so we get the integration of a given function, and now we have to print the integration, or we have to display the integration on a screen. For that we again use the printf function, that is the output function, which is used to display the output on a screen. And the message display on a screen, the integration of a given function is I is equal to percentage f I. The integration is a display on a screen by using this function. Then get ch, then the program or the body of a program is close with closing curly bracket. Now output of this program is enter the value of x0 is equal to 0, that is initial value. Then enter the value of xn is equal to 1, that is upper limit. x0 is a lower limit, xn is a upper limit. Then number of strips, that is n is equal to 10. Okay, then the integration of a given function is I is equal to 0.776130. Friends, now we have to see algorithm, flowchart and program to find the integration of a given function by using Simpson 1/3 rule. Again, Simpson 1/3 rule is integration of x0 to xn y dx, it is equal to h by 3 in bracket y0 plus yn plus 4 in bracket all odd term, that is y1 plus y3 plus y5 up to so on yn minus 1 plus 2 in bracket all even term, that is y2 plus y4 plus y6 up to so on plus yn minus 1. Here again h is a step size which can be found by using formula xn minus x0 divided by n. N is a number of strips, x0 is initial approximation or initial value or lower limit, xn is a upper limit. Then the y0 is equal to f of x0, yn is f of xn, and y1 is equal to f of x1. Okay, this process is carried out. Now first we have to see what is the algorithm for to find the integration of a given function by using Simpson one-third rule. First step is read x0 and xn. X0 is lower limit, xn is upper limit. Then read y is equal to f of x, that is a given function, and calculate the f of x0 and f of xn. Then read n, that is number of steps. Calculate step size by using formula h is equal to xn minus x0 divided by n. Then consider sum is equal to 0. Then next step is step 6. Sum 1 is equal to sum 1 plus f of x0 plus f of xn. Okay, the sum 1 represent y0 plus yn, or simply f of x0 plus f of xn. Now consider I is equal to 1. This is the initialization. Then sum 2 is equal to sum 2 plus 4 into x0 plus I into h. That is, sum 2 represent 4 in bracket all odd term. That is f of x1 plus f of x3 plus f of x5 up to so on f of x minus n. Then we have to initialize I is equal to I plus 2. That is, I is incremented by 2, and check the condition is I is less than or equal to 1. If I is less than or equal to n minus 1, then go to step 8. So that we get all odd term. Now consider I is equal to 2. Sum 3 is equal to sum 3 plus 2 into f of x0 plus I into h. Okay, sum 3 represent all even term. That is 2 in bracket y2 plus y4 plus y6 up to so on yn minus 1, or simply 2 in bracket f of x2 plus f of x4 plus up to so on f of x minus n. So all these are a even term. The even terms are calculated by using this formula, and for that we initialize I is equal to 2. Now I is incremented by 2 so that we get second even term. Okay, then when I is equal to 2, find sum, that is 2 into f of x0 plus I into h, that is x0 plus 2h. This process is carried out. I is incremented by 2, and check the condition is I is less than or equal to n minus 2. If this condition is satisfied, then goes to step number 12. Otherwise the execution of a program goes down, or this step is not true, that is I is less than or equal to less than n minus 2. If this condition is a false, then execution of a program goes down. And consider step number 15, that is a sum is equal to sum plus h by 3 into sum 1 plus sum 2 plus sum 3. Sum is a 0, h by 3 into sum 1 means f of x0 plus f of xn. Sum 2 means all odd term, that is 4 into f of x1 plus f of x3 plus up to so on f of x minus 1. Sum 3 represent all even term. Then print the sum and stop. Sum is our integration of a given function. Now we have to see what is the flowchart. First step is again start, then read lower limit, that is x0, and upper limit, that is xn. Then read number of iteration or number of strips, that is value of n. Then calculate step size by using formula, that is h is equal to xn minus x0 divided by n. Then consider sum is equal to 0, sum 1 is equal to 0, sum 2 is equal to 0, and sum 3 is also equal to 0. Then sum 1, it is equal to sum 1 plus f of x0 plus f of xn, means y0 plus yn. This is the first term. Then for here is again initialization. I is equal to 1. I is incremented by 2. Okay. I is incremented by 2 and check is I is less than n minus 1. If this condition is satisfied, then find sum 1 is equal to sum 2 plus 4 f of x0 plus I into h. Okay, 4 into f of x0 plus I into h. This represent all odd term. This process is carried out up to which I is less than or equal to less than n minus 1. Okay. Now again initialization. Here I is equal to 2. I is incremented by 2 and check the condition is I is less than n minus 2. If this condition is satisfied, then sum 3 is equal to sum 3 plus 2 into f of x0 plus I into h. That is 2 into f of x0 plus I into h represent all even term. Okay. So we get all even term. Okay. That is y2, y4, y6 up to so on yn minus 1, or simply f of x0 plus h, f of x0 plus x0 plus, now I is equal to 2, so f of x0 plus 2h, f of x0 plus 4h. So this process is carried out. Okay, up to which the condition is satisfied. So this loop is executed up to which the condition is satisfied, that is I is less than n minus 2. Now print or display sum. Sum is equal to sum plus h by 3. Sum 1 means f of x0 plus f of xn. Sum 2 means all odd term. Sum 3 means all even term. Then print the sum, that is the integration of a given function. Then stop. Now we have to see the program to find the integration of a given function by using Simpson one-third rule. Again, first is a hash include stdio.h. Hash include is a preprocessor directive. stdio.h means a standard input output function. .h represent header file. Then hash include conio.h, because we use the clear screen and get ch in this program, and therefore we use conio.h. Then hash include maths.h, because the mathematical operations are performed in this program, and therefore we use maths.h. Then define the function. Function fx is equal to square root of 1 minus x square. Now this is our function. Wide main, the codes are executed when we use this wide main function. x0, xn, h, s1 is equal to 0, s2 is equal to 0, s3 is equal to 0, and x. Here x1 is equal to 0, x2 is equal to 0, x3 is equal to 0. This is the initialization. But x0, that is a lower limit and upper limit, maybe consist of a decimal point. The number of steps which we calculated, that is h is equal to xn minus x0 divided by n, this h maybe also consist of a decimal point, and therefore all these are the floating point variable. Now integer I is integer, and the number of steps or number of iteration is also integer. It is a value. So clear screen, which is used to clear the previous output. Now by using output function, the message display on a screen enter the value of x0. Now this message is again enclosed in a double inverted comma and terminated with the semicolon. Printf is the output function which is used to display the message on a screen. Now when this message is displayed on a screen, we have to give the input to the computer. So that we use input function, that is a scanf, %f, because x0 is a floating point variable or it is a float, x0. Okay. So x0, this is the input which is given to the computer by using this input function, that is a scanf. Now we have to enter upper limit. For that, the message display on a screen is enter the value of xn by using output function printf, and now we have to enter the value of xn by using input function, that is a scanf. Scanf %f means because it is the floating point xn. So this is this value of upper limit is given to the computer by using this input function. Now we have to enter the number of n, number of value of n, or number of strips or number of iteration, so that the message is a display on a screen is enter the value of n. And by using input function, that is a scanf %d and n, we give input to the computer, that is input value of n. Now calculate step size by using formula h is equal to xn minus x0 divided by n. Now s1 is equal to s1 plus f of x0 plus f of xn, that is y0 plus yn. Okay. Then here consider for that we use for loop. In for loop, first is initialization, I is equal to 1, then I is incremented by 1, I is incremented by 1 up to I is less than or equal to n minus 1. That is, the for loop is executed up to this condition is satisfied, that is I is less than or equal to n minus 1. Now loop is x is equal to x0 plus I into h. Okay. When I is equal to 1, x became x0 plus h. Now I is incremented Okay, so it became the next value. Okay, so x2 is equal to s2 plus f of x0. Now we have to consider I is equal to 2. We have to consider the second for loop. By using this, we get all odd term. Now we have to find all even term. For that, we initialize value of I is equal to 2, and I is incremented by 2 up to I is less than or equal to n minus 2. That is, this for loop is executed up to this condition is satisfied, that is I is less than or equal to n minus 2. X is equal to x0 plus I into h, that is x is equal to x0 plus 2h, then x is equal to x0 plus 4h. This process is carried out and we get sum 3, that is sum 3, it is equal to s3 plus f of x0, which we calculated in a previous step. Okay, now the integration is h by 3 into s1 means f of x0 plus f of xn. 4 into s2 means f of x1 plus f of x3 plus f of x5 up to so on f of x minus 1 plus 2 into s3, that is 2 into all even term, that is f of x2 plus f of x4 plus f of x6 up to so on f of x minus 2. Now we have to display the integration on a screen by using output function, that is a printf. The integration of a given function is I is equal to percentage f I get ch, and the program is closed with the closing curly bracket. Output of this program is enter the value of x0. Consider value of lower limit is 0. The value of xn is equal to 1. Okay, and the value of n, that is number of strips, it is equal to 10, and so that we get the integration of a given function is I is equal to 0.781752. Friends, so in this lecture we discuss the trapezoidal rule and Simpson one-third rule. Trapezoidal rule and Simpson one-third rule is used to determine the integration of a given function. The trapezoidal rule is integration of x0 to xn y dx is equal to h by 2 in bracket y0 plus yn plus 2 in bracket y1 plus y2 plus up to so on yn minus 1. Here x0 is the initial value or lower limit, xn is a upper limit, h is a step size, y0 means f of x0, yn means f of xn, y1 means f of x1, y2 means f of x2, and yn minus 1 means f of xn minus 1. Simpson one-third rule is integration of x0 to xn y dx is equal to h by 3 in bracket y0 plus yn plus 4 in bracket y1 plus y3 plus y5 up to so on yn minus 1. So this y1 plus y3 plus y5 plus up to so on yn minus 1, this gives the all odd term. Okay, plus 2 in bracket all even term, that is y2 plus y4 plus up to so on yn minus 1. Again here is y1 is equal to f of x1, and x1 can be found by using formula, that is f of x0 plus h. Y2 is equal to f of x2, that is y2 is equal to f of x0 plus 2h. Okay, yn minus 1 means f of x0 plus n minus 1 into h, and yn is equal to f of xn. Now you have some assignment. First is write algorithm to find the integration of given function by using trapezoidal rule. This is first question. Second question, draw flowchart to find integration of a given function using trapezoidal rule. Third question is write a program to find the integration of a given function by using trapezoidal rule. Then write algorithm to find integration of a given function by using Simpson one-third rule. Fifth question is a draw flowchart to find the integration of a given function by using Simpson one-third rule. And the last question is write a program to find integration of a given function by using Simpson one-third rule. Write answer of all these questions and send this assignment on Google Classroom. Thank you.